In this video, we will see how a bit of visualization and applying first principle can be helpful in solving problems. So here we have 8 three-dimensional objects, or you can call them solids: cube, cylinder, cone, triangular prism, cuboid, sphere, a square pyramid, and tetrahedron. Against each of these objects, the name is written here. This is a correct combination of object and name. But suppose we make some changes, like suppose you put the cylinder here and cone here. Now this is wrong because out of the 8 objects, these 2 objects are not correctly placed. Suppose we make some more changes and move this sphere and say cuboid here. This is another arrangement which is wrong. If we say make some more changes like this is third arrangement which is again wrong. So in this case we are asked to find out number of ways it can go wrong. We just saw 3-4 examples of ways in which the arrangements are wrong. We have to find out in how many number of ways these arrangements can go wrong. Now if you start thinking whether this question is of permutation or combination, or it is application of say factorial or some similar concepts related to counting, and then you try to figure out which formula will be applicable here, then it may be quite confusing, and there are chances that you may land up making errors. So let us first try to see how we can solve this problem, and then we will just apply the first principle here. If we consider that we have places above these names like cube, cylinder, cone, triangular prism, etc. So there are 8 names here written, and then if above each name, if we consider one place where an object can be placed, then you have 8 places and you have 8 objects. So let us first find out in how many ways we can place these 8 objects at these 8 available places. And then out of all those ways, there is only one way which can be correct. And that way is that above cube you are placing the cube, above cylinder you are placing the cylinder, above cone you are placing the cone, and you are maintaining that. So if you do that, which is one way that is correct, then rest all other ways in which the objects are placed at different places, that will be wrong. You are seeing the example of all those wrongs. The arrangement which you are seeing right now on the screen, that is the right one. But if you make any other change, like if you put a sphere here and a square pyramid here, then it becomes wrong. So if we find the number of ways in which these objects can be placed at the places available, 1 less than that number will give you the number of ways it can go wrong. So let us see how we can find the number of ways in which these 8 objects can be placed at the 8 places. So we start from say cube. Initially we are assuming that all these places are empty, these objects are kept in a separate box. So from there we are picking one object and putting it at the different places. So at cube, from the box you can take out any of the 8 objects available there and place that object here. So what are the options? There are 8 options because all the 8 objects are available in the box. You can take any one and place that here above cube. So you have 8 options here. Against each of the options now, when you come to the place above cylinder, how many options you are having? Since one object you have already placed here out of 8, so now you are having only 7 objects left in the box. You can take any one of them and place that here. So against each of these 8 options for the place available here, you are having 7 options available. So you have to multiply 8 by 7. Then we come to the place above cone. Since 2 objects you have already placed here, now out of 8, only 6 are available. From that 6 you can take any one and place here. So now you have to multiply by 6. That way, if we keep moving, say here you will have 5 options, here you will have 4 options, then 3, then 2, then 1. So we have 8 into 7 into 6 multiplied by 5 into 4 into 3 into 2 into 1. These are the number of ways in which you can place the 8 objects at the 8 places which are available above the names written here. This is equal to 40,320, which is quite a good number. So there are 40,320 ways in which these 8 objects can be placed at 8 places available. Out of this, only one arrangement is going to be correct. So the number of ways it can go wrong, that answer is 40,319. Initially it doesn't look like this number will be so high, but then you can see the power of multiplication here and understand that how number of places and number of objects can impact this number. You can challenge yourself and understand the concept much better if you create some variations here, like instead of having 8 objects, you can keep lesser than 8 objects, like say 6 only, 8 places and 6 objects. Or 8 places you can have more number of objects, maybe 10, 12, and try to find out the number of ways in which it can go wrong, and again try to relate it with the concept of permutation, combination, etc. Here we are applying a condition that at one place only one object can be placed. Suppose this condition is modified and it is allowed to place more objects, more than one object at the same place, like you can put even all the 8 objects at the cube place itself. Then what will be the number of ways it can go wrong? If you are applying first principle, you can handle all these variations easily. But if you keep on identifying where permutation is required, where combination is required, and what formula to be applied, then you will find that these problems may be different and difficult problems for you. So the right strategy is to keep the basic strong and apply first principle wherever you can.